Our world is at a precipice in an ongoing crisis. The crisis, human pressure leading to an unprecedented environmental degradation, climate change, social inequality, and other negative planet-wide consequences. This crisis stems from a dramatic increase in human appropriation of natural resources to keep pace with the rapid population growth and the ever-growing demands, including food and energy, through the last few decades. Thus, the notion of development becomes crucial, more so when the kind of development in question has a significant impact on our future. The growing need for emphasis on the interactions between global environmental change and its impacts during policy making has resulted in the idea of sustainable development. The principle of meeting human needs and goals while taking into account the ability of the natural systems to provide the natural resources and ecological benefits that the human society and economy is based on. To this end, in the United Nations Conference held in 2012, 17 Sustainable Development Goals were proposed that are set to address the environmental, political, and economic challenges. These goals provide a framework for the government agencies and NGOs to design and refine their policy decisions in order to better accommodate the environmental aspect on the road towards sustainable growth and well-being.
This is Group 15 of Batch 2020 from NISER for the Economics course H205. In this presentation, we will be briefly illustrating the targets of SDG 15, the drawbacks, the challenges of the present policies, and will also propose some new policies that would help achieve the targets efficiently. The focus of this project is the northwestern district of Odisha, Sundargarh, the second largest in the state by size and the sixth largest by the population. SDG 15, Life on Land, and its 12 targets are listed here. The goal aims to protect, restore, and promote sustainable use of terrestrial ecosystem, forest management, combating desertification, and halt and reverse terrain degradation and biodiversity losses. To this end, Sundargarh has various policies and regulation under the national and the state government to achieve the set target. However, several issues remain, stemming from the inadequate execution of the policies and failure of the administrative machinery, cultural obstacles, inefficient distribution of information, benefits, and resources from top to grassroots level, and lack of effective policies. Some of the significant highlights are shown here. Inadequate allocation of the district mineral fund is the concern. Sundargarh is recognized as an industrial district with lots of major industries, 4 including glass, china clay, cement, fertilizer, etc. Yet more than half of the population earn their livelihoods from agriculture and elite sectors. This presents a significant challenge of eco-friendly agricultural practices which minimize the effects on land and the surrounding ecosystem while meeting the necessary demands. A district with 43% land area under forest cover, the region is topographically diverse with plenty of hills and the LB River flowing through. The hilly areas and the nearby flatlands suffer from significant topsoil erosion and land degradation from rapid runoff, further complicating the problem of the sustainable agriculture. Furthermore, particulate matter generated as waste from factories present are of major concern, with several implications for human and environmental health. The harmful effect of human intervention and encroachment of the forest ecosystem and its biodiversity is also alarming and need to be addressed. Therefore, in this presentation, we propose some policy measures to address the human aspects of achieving SDG 15.
A common policy weakness for various benefit and resource distribution schemes and policies is the lack of appropriate communication and distribution mechanism or system in place which can function effectively at the grassroots level. Thus, we propose the adoption of the following distribution model, specialized to address the agricultural problems and needs. Each village will constitute a base group, a collection of farmers and people working in associated sector registered as members. The base group is represented by a group of 5 people called the base representatives, composed of 1 teacher, 2 farmers, a local market representative, and a Gram Panchayat member. The base representatives from each village come together at the block level to form a collective, which is further represented by collective representatives with similar composition. The members may be changed periodically. It is a team of agricultural experts consisting of administrative representation as well at the district level, which will interact with the collective representative by the 2 channels as mentioned below. 1. Information dissemination. The collective representative from all blocks meet the expert team quarterly with necessary information and knowledge flowing top down. Then the knowledge is distributed among the respective base group. 2. Problems and grievance redressal. The collective representative from a block meets the expert team twice a year with information regarding problems faced at the field flowing bottom up. Then they are provided possible solutions and alternatives. Utilizing this model, we propose several solutions and alternatives to improve the agriculture systems in place.
Disposal of agricultural waste can sometimes be a cumbersome process. Mushroom cultivation can be an effective way of dealing with it. Along with managing the waste produced, it can serve as an efficient nutrient supplement that doesn't require substantial inputs and relieves the pressure on land. Mushroom cultivation can also help improve the socio-economic condition. The steps of cultivation are simple. It includes preparing the mushroom bed and leaving it for 14 days, spreading the spores and casing them, and finally twisting the mushroom at the base of the stem to remove them. We propose that awareness about this practice and its benefits be provided via the DM. Training may be provided to people on how to cultivate mushrooms along with necessary compensation. Women should be given more emphasis and allowed to bring their children if under 5 years. Contracts may be issued for the sale and delivery of supplies to isolated villages with lacking local markets. Mushroom products may be bought accordingly.
Along with agricultural waste, the rapid runoff resultant soil erosion and degradation coupled with water scarcity is a significant challenge. Growing turf grass is a durable and cost-effective solution. It reduces soil erosion, holds water runoff and improves soil's ecosystem, facilitating the degradation of organic matter in soil. Reduction in sedimentation losses and increase in microbial biomass pool by implications of turf grass is reported by several high-impact publications. Awareness can be spread about turf grass and their benefits through DM. Furthermore, the proposal includes setting up training camps where information regarding cultivation and maintenance can be given. Making green belts around crop patches may be promoted, especially in hilly areas. For turf grass cultivation in deserted lands, we propose organized recruitment across villages with help of DM. This has both environmental and economic benefit. Restored lands can be further utilized to construct beautification projects or sold to businesses.
The most cultivated crop in Sundargarh is paddy, which consumes a huge amount of water during its cultivation and processing. This ultimately leads to the production of huge amounts of wastewater that needs to be treated efficiently. Groundwater conceptual model for paddy irrigation can be a solution to this. Here, we propose the utilization of treated wastewater collected from fields to irrigate crops. Establishment of structures for collection and transport of wastewater may be supported via subsidies on the resources required. This may be streamlined through DM. Also, the government may set up treatment plants in proximity to villages.
Furthermore, an irrigation system specifically designed after studying the climate and soil type would help in mitigating water scarcity. This is also evident in wheat production, which is particularly high in the region. Thus, we propose an eco-friendly approach. Regular checking of soil and appropriate planning should be done. Also, irrigation in the pre-swing stage reduces weed growth. Weeds can create ruckus for which herbicides are used. Its use results in contamination of groundwater and degradation of the soil ecosystem. Instead of herbicides, hand waiting after 20 and 40 days of sowing reduces the weed density significantly. This method is much more effective than the use of herbicides. This practice should be positively reinforced by the spread of relevant information via the DM. Use of eco-friendly herbicides can also be promoted via selective subsidization. The decline in soil nutrient can be addressed by using the crop rotation method and precision agriculture. Periodic subsidization of relevant crops can help promote this practice. Precision agriculture ensures that the nutrient requirements of the crops are made in a sustainable manner. No tillage method is another method which involves planting crops by minimum topsoil disturbance. This can be done using disc seeders and agricultural drills. They are used to make furrows where seed is planted, then covered. Weed control is a major concern which can be combated by covering inter-rows with straw. Covering up with straw also protects the roots from burning.
Runoff and leaching are some of the leading causes of soil salinity. It severely affects the growth of the crops by seed deamination and contaminated water intake. We propose promotion of cultivating perennial plants in rotation with seasonal crops. This may be done through periodic subsidization of relevant crops and the spread of relevant information through DM. Regular inspection of the fields and introduction of certain bacteria accordingly can act as biofertilizers for the stressed soil. This can be done under the direction of district level team. Use of salt tolerant plants is the most essential tool to combat soil salinity in arid and semi-arid regions. Plant genetics and plant growth promoting bacteria can be used for the same. This is to be achieved through the novel technique of seed coating.
Seed coating is an excellent technique to bring precision agriculture to reality. In seed coating, we cover the seeds with adhesive agents to improve seed performance. Coating materials can be biopolymers, colorants, biocontrol agents, bacteria, etc. Research suggests that bacterial coating is a promising technique in this field. It has positive effects on seed germination, seedling establishment, nodulation in legumes, plant growth, and even on nutritional value. Plants developed from bacterial coated seeds are tolerant to biotic stresses like phytopathogens, as well as to abiotic stresses like drought, salinity, chilling, or heat. Bacterial coating finds wide application in wheat farming as well. Awareness about the benefits of seed coating can be spread via DM. Then training on agent preparation, coating, and other methodologies should be given to people having a certain level of qualification. To address this, block level training camps should be organized periodically. For those who successfully complete the training, subsidies should be given on electricity, resources used, etc. in the initial period of setting up agent manufacturing and seed coating units. This will enhance the availability of coated seeds in the market. Also, the government can set up agent manufacturing and seed coating units in collaboration with the Institute of Life Sciences and National Rice Research Institute. Subsidization of seed costs will encourage people to use coated seeds.
Fulfilling the nutrient requirements with minimal impact on the environment is difficult to accomplish. To this end, we propose extensive use of spirulina. Spirulina contains many macro and micronutrients and is best supply of food to alleviate the undernutrition problem among children and adults of Sundargarh. Awareness camp for spreading relevant information and benefits through DM is suggested. Periodic training camps at block level detailing the steps to grow spirulina at all scales will be provided. Government may set up spirulina production plants to encourage supply in local markets. By setting up spirulina plant in Sundargarh, job opportunities will be created and it will also help young minds of the district to get to know more about it and will encourage to pursue a career in research.
Another aspect that concerns the lives on land is the problem of increasing pollution that is mostly caused by the industries. Sponge iron industries are the most abundant in Sundargarh, which use fossil fuels as the source of energy that release particulate matter into the atmosphere. Particulate matter basically comprises a complex mixture of extremely fine particles and inorganic effluents. Specifically, PM less than 2.5 poses a serious health threat to all life forms including humans. As per the current estimate, the air quality index of Sundargarh is 151 and the major polluting particle consists of PM 2.5, which is 11.2 times higher than what is claimed to be a normal standard by World Health Organization. As a remedy to this problem, we can bring forth the use of nanofiber filters that are highly efficient in capturing PM 2.5, particularly for highly polluting firms.
Such excessive human intervention severely affects the ecosystems around us as well. A clear reflection of this can be traced back to negative changes in the various identifiers associated with biodiversity. Such excessive human intervention severely affects the ecosystems around us as well. A clear reflection of this can be traced back to negative changes in the various identifiers associated with biodiversity. Biodiversity provides us fundamental building blocks for many goods and services which a healthy environment provides. Other than the basic needs, it also provides us with recreational, cultural and spiritual nourishment. Thus, we propose organization of afforestation drives in schools and colleges alongside other government institutes on a regular basis, along with the supervision and tending of plants if required. This boosts awareness as well as raises concerns over its importance. Furthermore, we propose that classes and seminars be organized in all schools for the students as well as the staff. These address the need for biodiversity conservation, the problems and challenges, and the actions possible at the individual and collective level to achieve set targets. Also, we propose recruitment for the creation of Environment Supervision Teams (ESTs) in collaboration with the local community and the Forest Department. Functions include periodic supervision of the forested regions, more stringently so in ecologically sensitive zones, with tracking of flora and fauna species, deforestation activities, poaching and other illegal activities. More roles may be assigned later. Necessary compensation is to be provided during training and after employment.
We enlist here a small list of references we used in the creation of this work. With this, we conclude our presentation. We sincerely thank Professor Amrendra Das for motivating us to work on this project. Thank you.